I see that later on, there was an exam scheduled for the same day that Thursday folks were taking their exams, so that would even out as far as, the fairness of it. And I think we're just gonna have to go ahead and have that lecture exam on the same day. I hate to do that. If I move it up, we can't cover the material effectively. So I move it back for a full weekend of new material. And I'm not gonna add that new material to the exam, that would be way too big. So I think we're going to have to stick with it, because later on, I think November 10th, I think. The dates are hard for me to remember. I think November 10th, the Thursday folks will get the same dose. They'll get a lab exam, lecture exam the same day. I hope there are no others that would conflict, but that's the way I check it.
That microphone's supposed to make him louder. Is it different?
I hate that. I told you I don't like to have to do that, but it's just too much to have to shorten or lengthen it as much as we would. Pardon? Like we'll be here. So, I always ask before I continue discussing something, if there are any questions that anybody has before I go on with this. I think by now everybody knows that in lab they have a quiz next week over the blood. And, if Tuesday people know what to expect, I'll talk about it with the Thursday folks. Then very soon, I think probably within a week or so, we may be going to have on the blood lecture quiz too. That'll be online. It's not interfere with the class or anything. It's over the weekend. I'll just pop it up on the Angel. It'll be under the lesson section, a folder called quizzes in the lecture part. I'll talk more about how to do it and open it at that time.
So this weekend or the fall?
No, it wouldn't be this weekend.
No quizzes.
Following weekend, I might do it that weekend. It doesn't try to take your effort. As I said, the lecture quizzes are about 20 questions long. Usually I stick a few, most are multiple choice, but I stick a few fill in the blanks in there. If no questions, let's continue with plasma. Very important component of plasma. Remember I said it's 92% water, as you expect, about 8% solutes. That number can vary slightly depending on the fluid level in a person, that is how hydrated they are. When we talk about fluid level, we talk about hydration, either dehydrated or overhydrated or normal. And it can vary. About approximately 92 to 8, 92 water, 8 solute. And of the solutes, 8% would be plasma proteins. And there are different ways to describe them. You can just say they're proteins in the plasma, but I like to add the word resident. They're there in a certain concentration, not that they always all stay there, but they're measurable quantities within the plasma. Medically, it's important, and you don't need to worry about the medical aspects of it, but medically it's important because a measure of various plasma proteins indicate states of health problems a person might have. For example, if you're having a heart attack or you're having liver failure or something like that, liver disease, whatever, kidney problems, plasma protein levels can change. Measure those. Important too are the major types, and let's say a few words about them. Major types would be, if you looked at your text, you remember this one now, but albumins. Albumins are fairly common proteins in nature. One of the most frequent places you would see albumins would be in like egg white. There's a lot of them in there. But we have a lot in our body too, in our plasma. Makes about, of the plasma now, it makes up about 60% of the plasma proteins. So there are a lot of them in there. And they have some important duties. One of the things that plasma protein, or albumins rather, all of the plasma proteins add to this, of course, but they contribute a great deal to the viscosity, the thickness of the blood. And there are other things that do too, like red blood cells, etc. The viscosity, you know by now, viscosity is thickness, all right? B, and this is a little more complicated. We contribute to what we call the osmotic properties of the blood. Now let's step back and talk about osmosis a little bit, because that's what we're getting at here. You remember the definition for osmosis? Flowing of what? Just water. Now, truly, in truth, many things are moving back and forth between blood and the interstitium, between the cell and the interstitial fluid, etc. But we're strictly talking about flow of water, what induces water to move from one place to another. And what is it that really determines how much water will move through a membrane? The definition, first of all, as you remember, I should have repeated that. It's the movement of water through a semi or selectively permeable membrane from where there is less solute. What is solute, by the way?
Solids dissolved in.
The stuff dissolved in it, whether it's complicated like a plasma or simple like maybe just sugar or something. From where there is less solute to where there is more. Okay? For instance, I'll just put it down here at the bottom of the screen here. We have a membrane like this. We have something to write with. Here's my bag of goodies here. We have a membrane like this, and over on this side we have a solution with X number of solute molecules. This is the water-based solution. And over here we've got a lot more. The original greatest flow of water is going to be from this side of the membrane to this one. In other words, a simple way of putting it is to say water moves
Up.
the side. It moves more of it. Probably not the best definition for osmosis, but it's a good working one. And if you look at the blood and the small vessels carrying the blood through the tissues, and remember you've got plasma inside the blood vessels. What fluid is just outside? Bathes the cells. What did we call it yesterday? Interstitial fluid, right? The blood would have more protein, particularly albumins, because they contribute most to this, than the interstitial fluid would. So which one wins the battle in osmosis theory?
Blood.
Which one has more water moving to it?
Blood.
Yeah, but the plasma tends to draw the water effectively because it has more solutes, period. I mean, every solute contributes to it, but the proteins are very effective in drawing the water to the blood. And a simpler way of putting that is maintaining the water in the blood, keeping the water volume in your blood by this drawing, this movement of water from the surrounding fluids into the bloodstream. Later on, we're going to be looking more at the dynamics of this. It's not as simple as I'm making it out right now, because you've got pressure pushing fluid out of the blood. You've got osmosis pulling it in, so to speak. But having this amount of protein, and since 60% of them are the albumins, they would be the ones that contribute mostly to the protein component anyway of the osmotic pull of fluids into the bloodstream. And that would be a case where you have water. Which one is the water moving from the lower to the higher solute? Now, which one of these sides of this membrane here would represent more of the plasma?
The right.
The right side would have more of the solutes. I just put X's down there. A lot of protein, but you've got to remember that every single dissolved molecule or iron 2, within a solution affects osmosis. And we're just saying that so much albumin in the blood has a great effect on it. That's the point here. So a tendency to, I think this is a good way to put it, dog water, H2O. I meant to say be careful of this thing, will hit you like C for albumins. They transport some molecules. You'll find that in your body, quite often proteins act as taxis or transporters for other types of substances. Things like certain lipids and other molecules that need to be carried about in the blood. You don't feel too comfortable just dissolving the plasma of these molecules, so they hitch a ride on these various proteins. And certainly albumins would be part of that. The next kind of protein, and I'm not sure how easily I'm going to get this in here, I think I can anyway, would be the ones called globulins. Sounds like Halloween or something. Globulins are a rather large class of proteins, and about 35% of the plasmas would be globulins, so there's a good number there. Yeah, globulins do transport. Sorry for the aid here. This is like writing on one of those credit card machines. Easier to write on anyway. There is some transport. There are various types of globulins which can bind molecules and carry them, but one of those significant duties of the globulins would be to act as what are called antibodies. Now, does everybody know what an antibody is? If you don't, you will soon when we talk about blood types. Of course, took immunology and study a lot of different kinds of antibodies that attack many different invaders into your body. But basically, they are proteins that act as recognizers and destroyers of foreign invaders into your body, whether they be microbes, microorganisms, various chemicals, toxins that get into your system. Chemicals on cells like red blood cells and so on. And there are different kinds of antibodies, but they all come under the heading globulins. You don't need to write this down and memorize it, because we're not getting that far into it right now, but have you ever heard the term gamma globulin? There are alpha globulins, beta globulins. The gammas are the antibodies. Okay? Now, don't get antibody mixed up with antibiotic. That's a different thing. What's an antibiotic?
It's a pharmaceutical that you take.
That's a chemical you take or drug you take to kill bacteria in your system, control bacterial infection. An antibody is a chemical you produce, your immune system does, to recognize and cause the destruction of these invaders that are foreign. Invaders, by the way, are called antigens, generally speaking. That's the overall term for them. They can be microbes, chemicals, etc., but they are attacked by these antibodies. And globulins fit part of that category. I'm going to kind of squeeze it in. I'm not used to writing on the smallest screen here, but I'm going to kind of squeeze it into the top. There's another type that we will be discussing in this section. It's a specific type of plasma protein, a very important one called fibrinogen. Makes up about 4% of the total. It is always resident in your plasma. What is it used for? Blood clotting. There are a lot of chemicals involved in blood clotting, but a central one would be the fibrinogen. Okay? Notice the ending to this word. Look at the top of the screen. I'm sorry I had to put it up there. At the top of the screen, the O-G-E-N ending. There are a lot of chemicals in your body that end with this designation. And what it means is they are inactive. They're not doing anything at the present time, but with the right chemical environment, they can become activated and can perform an action. And in the case for proprenogen, the action, once it's activated, it would be to help in the clotting, be the central role player in the clotting process. It plugs up vessels, etc.